signal processing. So our interest will just be focused on what? DTFT. I told you the meaning of DTFT from my previous videos. So if you've not gone through the previous video, please do well to go through them, because it's actually the introductory part of the DTFT and you need to know the basics of DTFT. Are we together? Now I told you that DTFT simply stands for what? Discrete time Fourier what? Transform. So everything we'll be considering in our question will just be what? Discrete what? Signals. Are we together? Now from our first question, we're actually given to find the DTFT of a DTS. DTS here simply stands for what? Discrete time signal. Are we together? So we're given a discrete signal and we are asked, how can this discrete signal be what? Applied to DTFT to give us our new question, which is what? R raised to the power of n multiplied by u of what? N. Now I told you that when you are considering questions under DTFT, you need to be familiar with what we call our standard what? Signals. Standard what? Signals. Standard signals. And I told you that we have various standard signals, but in this course we do consider 4 standard signals, which are what? The step signal, the impulse signal, the exponential signal, and what? And the ramped signal. Are we together? So when you have a particular question given to you, the first thing you need to do is to consider if you are given a standard signal, because it is a must. You must be given a standard signal while considering what? Discrete time signals. Are we together? So what you do first is, first consider the question given to you if you have a standard signal, right? Now for us to solve this first question, let me change my pen to black, and I think we are good to go. Now from the first question we are given to find x of what? N, and they said x of n will be equal to what? R raised to the power of n multiplied by u of n, right? And what was the condition given? For what? Absolute value of r to be less than what? 1. Are we together? Now the first thing you do is you introduce your DTFT definition. DTFT definition. What is the definition of what? DTFT. Now I told you that DTFT, when you are considering DTFT, which is our discrete time Fourier transform, we say that if we're given a signal x of n and we apply this signal to what? A DTFT function, what we arrive at is a what? A frequency domain, which is what? X exponential what? JW. This is the concept of what? DTFT, where what you have here is called what? Your time domain, right? And what you have here is called your what? Your frequency what? Frequency domain. Now you were given that your time domain is equal to this signal here. So what do? In place of x of n, we are representing your discrete signal with a new discrete signal which you are given. Now if you replace this with a new discrete signal, you can now have that your new time domain will now be r raised to the power of n multiplied by what? U of what? N, applying DTFT to what we have here. What are we simply going to have? We are simply going to have our frequency domain, right? Which is what? X exponential raised to the power of what? JW. Are we together? Now, what are you now seeing? You are seeing that the only parameter that is changing here is your what? Your time domain, not your what? Frequency domain. Now, in essence, they are asking you to calculate for your what? Frequency what? Domain. Are we together? Now, how do you calculate for your frequency domain? I gave you a simplified formula that you use to calculate for your frequency domain by imputing the values of your time domain. Now, what's the formula? The formula is simply what? X of what? Exponential JW is equal to sigma n will be equal to what? Minus infinity to what? Infinity multiplied by what? X of what? N, right? Multiplied by what? Exponential minus JWN. This formula was given to you with respect to the discrete signal x of n, right? So since we are giving this formula in respect to the discrete signal x of n, we know that x of n is now equal to what? R raised to the power of n multiplied by u of n. Are we together? So since we are seeing x of n here, we are replacing x of n with your new signal, which is what? R raised to the power of n multiplied by what? U of n. So you have your new frequency domain equation to be x minus what? JW will be equal to sigma n will be equal to what? Minus what? Infinity to what? Infinity, right? Multiplied by R raised to the power of n multiplied by U of n, right? Multiplied by exponential minus JWN. Your equation still remains the same, but the only difference is in place of x of n, we are representing x of n with the new signal that was given to us, which is what? R raised to the power of n multiplied by what? U of n. Now, what's the next thing you do? Remember, I told you about standard signal, and I said for your standard signal, you need to know the standard signal given to you in your question, right? Now, let's talk about standard signal. Let's talk about standard signal. I told you have standard what? Signals, right? Standard signals. Now, I told you that for you to know the standard signals given to you, look at your question and look at how the question is being represented. We have 4 standard signals. We have the unit step signal. We have the unit what? Unit impulse signal. We have what? The unit exponential signal. And we have the last standard signal, which is what? Unit what? Ramp signal. Now, for your unit ramp signal is denoted with what? R of what? N. This is for discrete signal. Your exponential signal is denoted with what? A exponential what? Alpha n. This is for discrete signal. Your impulse signal is denoted with what? This is your impulse signal, while your unit step signal is denoted with what? U of what? N. Now, without nobody telling you what standard signal is there, you can now see that the signals that we have there is what? Is a unit step signal. Now, why are we taking the signals to be a unit step signal? We are assuming that all signals will have what? An amplitude of what? 1. That is why we are taking them to be what? A unit step signal. But in a case where they now give you your amplitude to be 2, 3, 4, 5, or as the case might be, you are now taking that signal to just be what? Step signal, if it is what? Unit step signal. Unit step signal is telling that the signal is what? 1. But when you're not having step signal, that is telling you that the amplitude of that signal is more than what? 1. Are we together? But what we have here is what we call our what? Unit step signal. Now, since you have this to be your unit step signal, the next thing that should come to your mind is, what is now your unit step signal? Are we together? But remember, from the question which you were given, you simply have U of n, right? So what you do is you tell your examiner that U of n is a what? A unit step signal. That's the first thing that should come to your mind. Is a what? A unit step signal. Now, how do you define a unit step signal? Unit step signal is defined as what? U of what? N will be equal to 1 such that n will be greater or less than what? 0. And U of n will be equal to 0 such that what? N will be less than what? 0. This is the definition of what? Unit step signal. Now, let's go back to our question. Remember that your unit step signal here will be 1, right? And if your unit step signal will be 1, n will be equal to what? N will be greater or less than what? 0. Are we together? Now, look at the condition that was given to you from your question. They are simply giving you a condition that R will be less than what? 1. So what comes to your mind? What are those values that will be less than what? 1? Is it not 0? 0 is less than 1, minus 1 is less than 1, minus 2 is less than 1, as the case might be. But in this case, we are not considering the negative value. But what are we considering? We are considering those values that are what? Less than 1, which is what? 0, right? Now, look at your definition for unit step signal. If u of n is equal to 0, n will be less than what? 0. So this condition here suits what? Suits the condition in your question. So you can tell your examiner that since you have, from your question, from your unit step signal, since you have u of n, right, to be equal to what? 0, n will be less than what? 0. And this condition suits your what? Your condition in your question. Are we together? So you simply have that anywhere you see n in your equation for your frequency domain, you represent that value with what? 0. Now look at your boundary condition. You were given boundary condition that n will be equal to what? Minus infinity to what? Infinity. So what do you think will be your new boundary condition equation? So from your question, you simply have that from the boundary condition, from your boundary condition, you were simply given that minus infinity to what? To infinity, right? So since you have that n will be equal to 0, you now have, since you have n will be less than what? 0, your new boundary condition will now be what? 0 to what? Infinity. So from your question, you now have your frequency domain, which is what? Sigma infinity, that n will now be equal to minus 0. What will you have here? R raised to the power of n multiplied by u of what? N, right? Multiplied by what? Exponential minus jwn. Are we together? So now remember that this was the equation for your what? Your frequency domain, which is x exponential what? Jw. This is your frequency domain. So what do? You recall that u of n is a what? Unit step signal. Unit step what? Signal. So since u of n is a unit step signal, u of n will be equal to what? 1. Are we together? Taking the amplitude of your unit step signal to be what? 1. So we are representing u of n with what? 1 in our what? Equation. So your frequency domain will now be what? X exponential jw, right? Will be equal to sigma n will be what? 0, because minus 0 is what? 0 to what? Infinity. And what you have here will be what? R raised to the power of n multiplied by what? 1. And this will be multiplied by what? Exponential minus jwn. So from what we have here, you're already telling your examiner that u of n here is a standard signal and it is a what? A unit step signal. Now, how can we simplify this equation by removing 1? You know that when 1 is multiplying everything, it still remains what? The same. So you simply have your final equation here to be what? Sigma n will be equal to 0 to what? Infinity r raised to the power of n multiplied by exponential minus jwn. 1 is multiplying this. So if 1 is multiplying this, it still remains what? The same, which is what? Exponential minus jw. Now, this is the equation for your what? Your frequency what? Domain. Remember, our interest in this question is to simplify the question to the what? Lowest term. Simplify your question to the lowest term. Now, what are you seeing here? You are seeing what? A power of what? N here. We're also seeing a power of n here. So we are simplifying this by taking one n outside. So if you take one n outside, you simply have the new value for your frequency domain to be what? X exponential jw, right? And this will be equal to sigma infinity to what? N, and n is equal to what? 0. R, remember, we want to simplify this by taking what? N outside. So if you take n outside here, you simply have r multiplied by exponential minus jw, right? So you simply have this to be r multiplied by what? Exponential what? Minus jw. And what will be the power of your question? The power will simply be what? N. Such that if you use your n to multiply into this bracket, you will still arrive at what you have here. So what we just did was we just simplified our what? Our equation. Are we together? Recall from our elementary maths when we talked about geometric progression and the sequence and series. We had an equation for infinity series. If you want to get an equation for infinity series, and we said for you to get the equation for an infinity series, we have that what sigma n will be equal to 0, right, to what infinity, and this will be what a raised to the power of what n. Now this equation will be equal to what 1 divided by 1 minus what a. This equation is for what infinite what geometrical series. This equation is for what infinite geometrical series. So we are using this equation to represent what, recall that this equation is what infinite geometrical series. Somebody will ask me, why are we now recalling this equation? We are recalling this equation because what we have here is similar to what we have here. If you look very well, if you look very closely, you can see that a here can represent what everything here, and this is what raised to the power of n, with the condition that this is what sigma, which is summation of what n will be equal to 0 to what infinity. That is what this equation is having. That is why we recall the equation for what infinite what series, and we said for your infinite series equation, you will simply have that this will be equal to what 1 divided by 1 minus what a. Remember, our interest is to simplify your question to the what lowest term. You can still leave your answer to be this, right? But leaving your answer to be this will still tell the examiner that there is a way to simplify this. So why didn't you simplify it to the lowest term instead of leaving your question, your answer open like that? Are we together? So what we are simply doing is we want to simplify our given signal to the lowest what term for somebody to understand. Are we together? So if we are to represent what we have here with this equation, we'll simply have that what we have here, which is what sigma n is equal to 0 to what infinity of what r raised to the power of exponential minus jw, all in bracket raised to the power of what n, will now be equal to what 1 divided by 1 minus, in place of a, we are representing a with everything here, such that your a now will now be what r exponential what minus jw minus what jw. Now this is telling the examiner that you've simplified your question to the what lowest term for people to what understand. Are we together? So this is the answer for your frequency domain of your what given signal, which is what r raised to the power of n multiplied by what u of what n. Now let's go to the next question. So basically, next question is we're given to find the DTFT of a signal. And what is the signal? We're given this signal is equal to another signal, right? Now looking at this signal, this will tell you that this is an what? This is an impulse what? Signal. Impulse signal. So what you are going to do is you are going to use the concept of what impulse signal with respect to the concept of what DTFT. Are we together? Now taking our question 2, if we are asked that what x of n will be equal to what our impulse signal when we apply what our DTFT. So you should know that if x of n is equal to your standard signal, which is an impulse signal, what will be the concept behind your frequency domain, or what will be the answer for your frequency domain? That should be what should be playing in your mind, right? Now, what's the concept behind DTFT? The concept behind DTFT is if we have a time domain, which is x of n, if you subject your time domain to what DTFT, your time domain will simply yield out what a frequency domain, which is x exponential what jw. Now with this, the examiner will simply see that, oh, we are using the concept of what DTFT to solve what we have here, right? Now recall that you were given that x of n will be equal to what impulse signal, which is this. So what we are simply doing is we are representing x of n with our impulse what signal. So the new concept for your DTFT will simply be what your impulse signal subjected to what DTFT will simply yield out what a frequency domain, which is x exponential what jw. With this alone, you're already making the question so unique that you are telling them that impulse signal will be subjected to DTFT, and your DTF signal will yield out what? A frequency domain, which is what? X exponential what? JW. Are we together? Now, the next thing that should come to your mind is recall we have what? An impulse what? Signal. So what comes to your mind is what is now the concept behind impulse signal, or what's the definition of what? Of an impulse signal. Now take down the definition of an impulse signal is simply what? Impulse signal is defined to be equal to what? Impulse signal will be equal to what? 1, such that your n will be equal to what? 0, and impulse signal will be equal to what? 0, such that what? N will not be equal to what? 0. This is the definition of what? Impulse signal. Now remember, when we are considering your impulse signal here, we are considering what? Unit impulse signal. So since we are considering unit impulse signal, we are taking that your amplitude for your impulse signal will be equal to what? 1. Are we together? Remember, our interest is what? Our frequency domain, which is X exponential what? JW. So what comes to your mind is, what is the formula for what? Frequency domain. Remember that frequency domain is given to be what? Exponential JW, and this is what? Sigma n will be equal to minus infinity to what? Infinity, multiplied by x of n, right? Multiplied by exponential minus jwn. This is the formula for what? Frequency domain. But remember, from this formula, we can see that we are talking about frequency domain in terms of what? X of n. Now, but we know that x of n is now equal to what? Impulse signal. So we are considering, the next thing you should be talking about is considering frequency domain in terms of your impulse signal, which is what? Delta n. Are we together? So if we are considering frequency domain in terms of delta n, we'll simply have that our new frequency domain equation, which is x exponential jw, will be equal to what? Sigma n will be equal to what? Minus infinity, right? To what? Infinity, such that delta n will be multiplying what? Exponential minus jwn. With this now, your examiner can now see that you are considering what? The formula for frequency domain in terms of your impulse what? Signal. Are we together? But remember, what is the definition for your impulse signal? We define impulse signal to be what? Impulse signal will be equal to what? 1, such that your n will be equal to what? 0. And impulse signal will be equal to what? 0, such that your n here will not be equal to 0. Now remember, we are taking our impulse signal here to be what? A unit impulse signal. So if this is a unit impulse signal, if this is a unit impulse signal, that is telling you that delta n here will be equal to 1. And when delta n is equal to 1, n will be what? N will be equal to what? 0 from our definition. This is what we have in our definition. So since we are taking impulse signal to be what? A unit impulse signal, we are saying that delta n will be equal to 1. And if delta n is equal to 1, n will be what? Equal to what? 0. So anywhere we see n in your given equation, you are going to what? Impute what? 0. Are we together? Now let's go over to the new equation for our frequency domain. We have that n here is equal to what? Minus infinity. So what's this telling you? This is telling you that your n here will be what? Minus what? 0. What is your signal here? Is a standard signal and is an impulse signal. So since it's an impulse signal, it's having an amplitude of 1. So you have 1 multiplied by exponential jw what? N. What are we seeing here? This is another n here. So your n here will also represent what? 0. So you have your new equation for your frequency domain will be given as sigma n to be equal to 0 to what? Infinity. We know that what we have here is a unit impulse signal, and we are taking our unit impulse signal to have an amplitude of what? 1. So we have 1 multiplied by exponential minus jw raised to the power of what? 0. Why are we imputing 0 here? Because n is equal to what? 0 from the definition of what? Impulse signal. Are we together? Now remember, Anything multiplying 0 is what? 0. So from what we have here, you have sigma what? Infinity to what? N will be equal to 0, such that 1 multiplied by exponential 0 multiplying everything here will simply give you what? 0, right? So we have this to be what? 1 multiplied by exponential what? Raised to the power of 0. Now remember, recall that when you have exponential raised to the power of 0 will be equal to what? 1. Are we together? So if exponential raised to the power of 0, this will be equal to 1. What are now the boundary conditions? The boundary conditions now, are what? 0 and what? Infinity. Are we together? So since we've known the boundary condition and we know that exponential raised to the power of 0 is 1, we'll simply have this to be what? 1 multiplied by what? 1. And if you have 1 multiplied by 1, this will simply give you what? 1. Now, this is the final answer. Now, this is telling the examiner that you've already what? You've shown that from your question, if you apply a DTFT signal, if you apply the DTFT to a DTS signal, which is what? X of n, and if X of n is equal to what? An impulse signal, you simply have your frequency domain of that impulse signal to be equal to what? 1. Are we together? Now let's consider the last question there. Now from the question we are given, we are asked to what? Show that the absolute of what? Exponential minus JW will be equal to what? 1. So our question we're given to what? Show that the absolute of what? Exponential minus JW will be equal to what? 1, right? Now what are the parameters here? These are exponential, this is our imaginary part, and this is called what? Your angular what? Velocity. Are we together? And they said when you take the absolute of this will be what? Equal to 1. Now how do you solve this particular question? Remember, this is not a question that you were given to apply the concept of DTFT to get a DTS what? Signal, right? We're asked to what? To show that what we have here will be equal to what? 1. Now, how do you do that? The first thing you do is to recall an equation that is similar to what you have here, because what you are expected to do is to simplify this such that when you simplify and you apply the absolute of this value, you arrive at what? 1. That's what you do. Now, recall that when we are talking about Euler's method, let's recall Euler's method. And what's the concept behind Euler's method? Euler's method simply says what? Exponential j theta will be equal to what? Cos theta, right? Cos theta plus j sine what? Sine theta. Now, why are we recalling this concept? We are recalling the Euler's method because what we have here is what? A similar concept or a similar what? Parameter with what we have here. So in essence, we are simply seeing what? J theta. In this case, we are seeing j theta, which is imaginary part multiplied by what? Your theta. But on this case, we are now seeing what? Imaginary part multiplied by what? Angular what? Velocity. Are we together? So in essence, we can say that what? Theta here will be equal to what? Minus what? W. In essence, we are saying anywhere we see theta, we are putting what? JW. Now, if you impute theta to be what? Minus W into your Euler's method, you now have your new Euler's method equation to be what? Minus JW, which is what we have here, will now be equal to cos, in place of theta now, we are now using what? Minus W, not what? Theta. So we have minus W plus what? J sine what? Minus what? W. Are we together? Now, what we are seeing here is you are seeing what we call your real part and your what? Your what? Imaginary what? Part. So you can differentiate your real part from your what? Imaginary part. What are we seeing here? We are seeing what? A trig function which says what? Cos minus W, and another trig function which says what? Sine minus W. Now recall, when we are talking about the even slash the odd properties of trig function, recall that when we are talking about odd slash what? Even properties of our trig function, trig what? Function, we have that when we are considering your cos, if you have cos minus theta, this will be equal to what? Cos what? Theta. But if you have sine minus theta, this will be equal to what? Minus sine what? Theta. Now this is what? The property of what? Trig function. This is what? The property of what? Trig function. So in essence, in place of what? Theta, we are using what? We'll be using what? W to represent. But cos what? Cos minus W will now be equal to what? Cos W, not theta in this case. But when you're now considering sine, you now have that what? Sine minus W will now be equal to what? Minus sine W. Are we together? So what we are trying to do is we are trying to simplify what we have here to the lowest what? Term. So since we have cos minus W to be equal to what? Cos W, and sine minus W to be equal to what? Minus sine W, we are replacing this to our given question for what? Euler's method. So you now have your new Euler's equation to now be what? Exponential minus JW will now be equal to, in place of cos minus W, which is what we have here, so in place of cos minus W, we are imputing cos minus W with what? Cos W. So we have this to be cos W plus, right? That was the equation. So this is what we have plus here. Now we are now having plus J, right? So we have plus what? Plus J into what do we have here? Sine minus W. And what's the trig property function of sine minus W? We've already gotten the trig property function for sine minus W to be what? Minus sine W. So what we have here will now be what? Minus what? Sine W. Are we together? Now looking at our question, is it simplified? No, it's not simplified. Why? It's because we are having plus here and we are also having minus here, right? So we have plus times minus, it is what? Minus. So if you simplify further, you simply have this to be what? Cos what? W minus J sine what? W. Now we can now see our new change for what? Our real part and what? Our what? Imaginary part. Where for your real part, you simply have this to be what? Cos W. And for your imaginary part, you simply have what? Minus sine what? W. Are we together? So from your given question, you've been able to identify your real part and your what? Imaginary part. Are we together? Remember, we can call this our real part to be what? A, and we can call our imaginary part to be what? B, right? Making your Euler's method to be what? Exponential minus JW will now be equal to A plus what? JB. Are we together? A plus what? JB. Are we together? Now recall that when you are to apply, if we are to get, remember our question is to get what? The absolute value of what we have here, right? The absolute value of what we have here is simply what? The magnitude of exponential minus JW. And they said when we get the exponent, if we apply the magnitude of exponential minus JW, that will be equal to what? 1. Are we together? If we have represented our real part to be what? A, and also represented our imaginary part to be what? B, right? If we are to apply the magnitude, if we are to find the magnitude of our Euler's method, you will simply have the magnitude for your Euler's method, which is JW, will be equal to what? Remember, when we are considering magnitude, then we are applying the concept of what? Square root and what? Square. I come again. When we are to find magnitude, what do you do to the right side, the right hand side of your equation? Is to apply the concept of what? Square root and square. What do I mean? From what we have here, this will be simply be what? We are simply going to get the squares of what? A, and also the squares of what? B. Are we together? This is the concept of what? Magnitude identification. This is the concept of what? Magnitude, right? But what we have there, we used what? We used A and B to represent what? Cos and sine, right? So from what we have here, if we represent these symbols, we can represent A, which is our real part, to be cos W, and we also have our imaginary part, which is B, to be what? Minus sine W. So in place of A and B, we can represent A and B as what? Cos W and what? Minus what? Sine W. So we'll simply have that the magnitude of our Euler's method, which is minus JW, will now be equal to